Hi everyone, I've had a request for a video on pressure, so that's what today's video is going to be on. I think I'll probably start with an overview and I'll talk you through it like this, and then I'll probably turn to explain everything to talk through some examples of questions that might be asked, and then hopefully we'll have a good video out of that. The crucial thing about pressure is it's about the amount of force which is applied over a certain area. So if the force is applied over a small area, then our pressure is going to be really large, and if our force is applied over a large area, then the pressure is going to be much smaller. Did that even make sense? Let's go through that again. So the point is, when you're calculating pressure, you need to know about both force and area. To have a high pressure, you're going to need a force which is applied over a small area, and to have a low pressure, you're going to need a force which is applied over a large area. So if we look at our formula triangle, we see that it contains force, area and pressure. Force goes at the top, then it goes area, then it goes pressure. It's worth learning this triangle. We have many things in everyday life which will be designed in order to either increase pressure or decrease pressure depending on their use. Something like a knife or a drawing pin, for example, they need to be sharp. So what you need to do is apply a force over a very small area to increase the pressure. And that's to make knives really sharp so you can slice through things, and it's to help you stick a drawing pin in the wall. You'll notice that the drawing pin has a nice wide top, and that increases the area, therefore decreasing the pressure, and that means that the pin doesn't actually stick itself into your thumb, because that wouldn't be very helpful, of course. There are other applications of pressure which you need to know about, and that will be applications which aimed at decreasing pressure. So things like elephants' feet and camels' feet, they don't want to be sinking into the sand, so they need to be applying a much lower pressure. The way they do that is by having really large feet, because what these do is they spread the force, so the weight of the animal, over a really large area to help decrease pressure, and that will help stop the animal from sinking into the sand. Similarly, skis and snowshoes, you don't want to be sinking into the snow, you wouldn't really go anywhere, so that wouldn't be very helpful. So what we have here is a large area, because the ski or the snowshoe is very big. The weight is therefore distributed over a very large area, and therefore the pressure will be decreased, so we won't sink into the snow. In terms of knowing the units of pressure, if you look at the triangle, you'll see that pressure is force over area. What are the units of force? Newtons. Units of area, things like meters squared or centimeters squared. So therefore, the units of pressure will be newtons divided by meters squared, which is otherwise known as a Pascal. So 1 Newton meter squared is the same as 1 Pascal. So it depends on the exam question as to which units they'll want you to use. Let's quickly touch on pressure at depth, so under the sea and at the top of the mountain. Quite simply, you find that pressure increases as you go deeper underwater, and that's simply because there are more particles above you. So they'll be colliding with each other, generating pressure. You find that pressure decreases very much at the top of a mountain, and that's just because there's simply less air above you, so less particles. So what you will find, for example, if you have a crisp packet and you have it at sea level, it will be like a regular crisp packet, quite squashable. What you find if you take it up in an aeroplane is that it will expand like a pillow, and it will be really puffy. And that's because when it was sealed at sea level, it had a certain number of air particles in it which were exerting a pressure by colliding with the walls of the crisp packet. And you also found that there was an equal number of particles colliding on the outside, so it kind of had an even pressure. However, when you take it up in an aeroplane, like I said, there's far less particles up there, so there'll be fewer particles colliding with the outside of the packet and far more pressing out from the inside of the packet. I hope that makes sense. So what you find is the net movement effectively is for air particles to be pushing out of the packet, and you end up with a really puffed up crisp packet. I hope that made sense. Do let me know if you have any questions on that. I think now actually I'm going to start using Explain Everything to run through some questions, and hopefully they'll be really helpful. Here I'm looking at a question, so which exerts more pressure on the ground? A tank with a weight of 80,000 newtons or a cyclist with a weight of 1,000 newton? The tank tracks have a contact area of 10 meters squared, and each of the cyclist tyres have a contact area of 0.6 meters squared. So what you need to do is begin by drawing the triangle to help you sort out your formula. So it looks like this: force is at the top, then it goes area, and then it goes pressure. So I'm going to change to black. So I'm obviously looking at the pressure, so I need the form of the equation which looks like this: force over area. I'm going to start by looking at the tank. So its pressure will be its force, and obviously that will be the 80,000 newtons. Why? Because weight and force have the same units, so that is newtons, and therefore we can use them interchangeably. So that's 80,000 divided by the area, which I've been told is 10.
And here's the answer 8,000 newtons per meter squared. Now let's look at the cyclist. Okay, so the pressure will equal the force again, which is this time 1,000 newtons, divided by the area. Now don't make a mistake here. The area is 2 lots of 0.006. The reason being because obviously the cyclist has 2 tyres. So I'm going to do 0.06 times 2, which equals 1,000. Please don't let me run out of space. By 0.012. I'm going to use the calculator here. And the answer here is 833 newtons meters squared. So, as you can see, it's obvious that the cyclist exerts more pressure because their pressure is 83,333. So make sure you write that the cyclist is the answer.
I really hope you enjoyed this video. Don't forget to subscribe to my YouTube channel and like my Facebook page, Science with Hazel, as I think you'll find some extra help there, and I'll see you guys next time. Bye!